Let's begin. Today's September 17th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 9, 14, 18, 19, and 20. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. So criteria card A looks at our 3-digit solution, and the Turing Machine will let us know how many of those digits are 3. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card B looks at our 3 digits, triangle, square, and circle, and will let us know which one is the absolute smallest. So should triangle be the smallest, should square be the smallest, or should circle be the smallest? Criteria card C again looks at our 3 digits, triangle, square, and circle, but this time it'll add them up, and the Turing Machine will let us know whether that sum is an even quantity or an odd quantity. Criteria card D will look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E again looks at our 3-digit solution, but this time will let us know a little bit about its structure, so to speak. Specifically, one of the scenarios is that there are no repetitions, meaning that all digits are unique, as in the example 125, or it could be a double number where there's a single digit repeated, as in the example 112, or it could be a triple number, a single digit repeated 3 times, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 5 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I want to test is criteria card C. Okay, so the Turing Machine does not approve of my proposal. Notice that since we are adding them up, let's go ahead and do that. 3 plus 1 is 4, 4 plus 4 is 8. That sum is an even quantity, but the Turing Machine does not approve of it. So it's basically letting me know that the sum of the 3 digits is actually, or should actually be an odd quantity. So let's go ahead and type that up. So that triangle plus square plus circle should be odd. Okay, so even though it's still pretty early, we really can't cross out anything. What we can say of a sum total of 3 digits to be odd is that, well, one, you could have all odds, and then the other scenario is that you could have 2 evens and then an odd. Whenever you add 2 evens, that sum is even, but if you want the overall sum to be odd, you have to introduce an odd. Now, I may have said the word pair. It doesn't necessarily have to be equal. It just means I meant to say that they had to be of the same type. So either 2 evens and an odd or all odds. But we do have this one criteria card E that can tell us whether maybe we have all unique digits or if there's a double. So let's go ahead and test criteria card E. Okay, so if you look at my proposal 314, those are all unique digits. There are no repetitions, and the Turing Machine agrees with that. So let's go ahead and type that up in our notes for section E, and that is that the solution has no repetitions. Now that doesn't clear up if there are um, two evens and an odd. It just means that, yeah, we just know that they're all unique. So, well, the good thing about that is if there are evens, it's going to be a 2 and a 4. And obviously, if there are odds, it could be, one of each. So we still have, a lot to get through in this puzzle. We do have that criteria card A that'll let us know if there's a 3. So what happens if there's a 3? If there's a 3, well, yeah, I think you can still have two evens. Now, if there's no 3, yeah, what's interesting is if there is no 3, that means it must be two evens and an odd. Because if you have no 3 and they're all distinct, you can't have an all odd solution. So that might be interesting. I don't know if it's worth the risk, because if there, I do have a 3 in my proposal, and of course you can only have a 3 or no 3, right? You can't have, because of the uniqueness or no repetitions, you can't have 3, you can't have 2. It's either there or not. So that would be interesting if there is no 3. It may be worth the risk. Yeah, let's go ahead and test criteria card A. Okay, so the fact that I have a 3 and the Turing machine does not approve that lets me know that, yeah, there should not be any 3s in our solution. Okay, I think the risk paid off. So let's go type that up in our notes, that we'll say that the solution has no 3-digit. Okay, again, there can't be 3 or 2 because of the uniqueness, and the fact that I do have a 3 in my proposal and the Turing machine does not agree with that means that there is no 3. So let's go ahead and cross out all of the 3s, since again, the Turing machine indicated that the solution should have no 3s at all. And we also now know that there should be 2 evens, because you can't have an all odd unique solution in digits without a 3. So very interesting how that works out, that combination of criteria cards and and what they resolve to have basically told us, yeah, you've got a 2 and a 4 and an odd. You just don't know which. So let's say, yeah, let's go ahead. I'm just going to put a note in section C. It doesn't really matter where. Let's see, is there a little lag? There we go. We'll say that the solution has a 2, a 4, and an odd. Okay, so the question then becomes, well, could 1 be the smallest? Oh, and by the way, we have completed this first round. We did complete our 3 Turing tests. Now we'll go into the phase where we'll discuss how to construct a good second round proposal. Okay, so the things that we did not test were criteria card B, the smallest digit, and the sum of the first 2 digits, and comparing that sum to 6. Well, we do have, again, 2 evens, typically, not always. You could have the first 2 add up to 6. So that would be the 2 and the 4, and then you would have circled, forced into some value, typically. And I guess the only way to sort of order it would be if maybe, again, if the sum of the first 2 is 6, that square is the smallest, forcing it to be a 2, which would mean that triangle would be a 4, and because a square is the smallest, then that would mean that circle would have to be 5. So let's go ahead and try that out. So I'm proposing 4, 2, 5 as a possible solution. So let's go type that up, 4, 2, 5. Well, yeah, I think, if the sum of the first two is 6, either or, it could be even 2, 4, 5. Yeah, but I already typed it up, so let's just go with it. So the whole reason for that proposal was criteria card D. So let's see if the sum is equal to 6. Okay, so yes, the sum of the first two are 6. So let's go ahead and type that up. And that was section D. So we'll say that triangle plus square should be equal to 6, since that's what the Turing machine confirmed. So that means that we know that the first two have to be either a 2 or 4, because, yeah, again, we did say that you can't have an all odd, so yeah, you do have 2 and 4, so it should be both triangle and circle must be, triangle and square must be evens. So we can go ahead and cross out all of the odds, and we can do the same for circle, except there we're going to cross out all of the evens, because we know circle has to be the odd digit. Okay, so yes, we know the sum of the first two are 6, which would lead us to say that there are 2 and 4. And so, yeah, let's go ahead and test, because there's no way to deduce what it could be. Yeah, we don't even know which one's the smallest. Yeah, this should be it. Yeah, this will be interesting. Let's see, can circle be 1? Yeah, I don't think circle can be 1, because if it were the smallest, there'd be no way to order triangle and square. You wouldn't know if it's 2, 4 or 4, 2. Yeah, so I'm pretty sure it's going to be either triangle or square, and circle is going to default to 5. So let's see, yeah, and there's no way to deduce which one. So let's go ahead and test B. Okay, so I chose the wrong one. That's okay, it was a 50-50 among, well, I say it's 50-50 at this point. Before, not so much. But since we've sort of concluded that, yeah, either triangle or square needs to be the smallest, I chose 2. 2 is my smallest digit. It is not square. So I'm going to type up that I'm going to deduce that it should be triangle. That's the smallest. So let me go ahead and type that up. And I'm saying that I'm deducing because technically I still do have 2 options, but because I've already sort of argued that circle can't be 1 because there'd be no way to order 2 and 4 for both triangle and square. So triangle is the smallest. And so what that means is that triangle is 2, so we can cross out the 4. And that means that square is 4. And as I stated, I don't believe circle can be 1 because then you can't order it. So yeah, it looks like the solution is 2, 4, 5. So let's go type that up. Okay, Well, let's go verify. Okay, so 2, 4, 5. There we go. Fantastic. So we got the right solution. And now let's go ahead and see how we did with versus the Turing machine. So we did test all 5 criteria cards. So 5 out of 5. That's always, a good starting point where, we probably did beat the Turing machine. So we did do ACE in the first round, and E was the correct one. And then we did the remaining 2, BD, in the second round, and D was correct. So let's go type that up. So ACE in the first round. So A was wrong, C was wrong, E was correct. And then second round, B was wrong, D was correct. And let's see how we did. Wow, surprisingly, we beat it by 2 questions. That's interesting. I really do think, again, probably by stroke of luck, that we did test the first 3 criteria cards were so instrumental in the sense that we were able to find out that it was going to be a 2, 4, and an odd. So those 3 criteria cards coming together in their, and how they resolved, really, I believe, focused our attention to 2, 4, and odd. And so that was critical. Well, what do you think? How did you solve it? Did you notice anything about my solve in the video? Did I miss something? Add those thoughts to the comments. If you liked the video, please do give it a thumbs up so that more people can find this channel. And of course, hit subscribe if you don't want to miss out on any future videos. Well, until next time, have a great one.